lesson, you will encounter such things as titration, endpoints, neutralization points. At the end of this lesson, you'll be able to describe steps involved in titration, determine the term endpoint, use the idea of titration to establish formulas to be used in experimental calculation. Let's look at the big picture. Titration is an experimental procedure involving the reaction of an acid and alkali. You are a lot familiar with this now. In titration, the acid and alkali solution react to give the endpoint, shown by an indicator. Calculations are then performed to find the concentration of the acid or the alkali. In titration, you must know the concentration of one of the solutions. Not much is required for titration. You will only need burette, pipette, retort stand, conical flask, acid solution, an alkali solution, as well as an indicator. There are a few steps involved in titration. One is for you to wash and dry all your apparatus. Step 2, you have to collect some acid solution in a beaker and the alkali in another beaker or a flat bottom flask if you want. Remember to label them. And step 3, you have to pipette 25 ml of the base into a conical flask and add a few drops of indicator. Then, in step 4, you have to clamp the burette to the retort stand. It should be adjusted high enough for the conical flask to be placed underneath. Fill the burette with the acid by means of the funnel. Remove the funnel and adjust the acid level to the 0 calibration mark. In step 5, you have to place your conical flask, which already has base in it, directly under your burette and get set for titration. When you go on by adjusting your flask under the burette, you begin your titration. You are going to hold your conical flask with your left hand, and then you click and you hold the burette tap with your right hand, and then you titrate. In the equation of reaction, divide by the mole of the base in the equation of reaction. That is to say, the mole ratio of acid to base is the same as that in the equation of the reaction. So, we can effectively bring out the representatives of this mole as this. Now that you've done this, here is your task. Experiment class. Now for this experiment, Bukola will be effectively carrying out a titration. So you sit back, watch, and send your questions to our website.
Hello and welcome back. I'm going to carry out a titration using sodium hydroxide and hydrochloric acid as my reagent. First, I'm going to use a pipette to get 25 cm cubed of sodium hydroxide. Now that I have it, I'm going to put it into the conical flask. Next, I'm going to add acid into the burette until it's at the 0 mark. Now I'm going to add 2 drops of the indicator methyl orange into the base. The base is going to turn orange. Now I'm going to carry out the titration. I'm going to add little of the acid, small by small, and I'm going to shake the conical flask until the end point is reached. I know that I'm approaching the end point when I see some drops of pink. Now that it's almost pink, I only need to add 1 more drop to make it completely pink. I'm going to check my burette to see how much acid I have used. It has now been neutralized. As you can see, the solution has turned pink. And I used 21.5 cm cubed of acid, and I'm going to record that. Thank you. I carried out the titration to figure out the concentration of the acid, hydrochloric acid. I already know the concentration of the base I used, which is 0.5 moles per dm cubed. Now, before we can find the concentration of the acid, we need to figure out the average volume of acid used during the titration. In the first titer, I used 21.5 moles per dm cubed. In the second, I used the same, 21.5 moles per dm cubed. If I add this number, I'm going to get 43. And to take the average, you say 43 divided by 2, and you're going to get 21.5 moles per dm cubed as the average volume of acid used. Also, we need to see the equation for the reaction. Sodium hydroxide plus hydrochloric acid will become a salt and water, which is sodium chloride and water. The mole ratio of sodium hydroxide to hydrochloric acid in this reaction is 1:1. So now I'm going to calculate the concentration of acid in moles per dm cubed. The concentration of acid is going to equal the concentration of the base times the volume of the base times the moles of acid divided by the volume of acid times the number of moles of the base. So, the concentration of the base is 0.5 moles per dm cubed times the volume of the base used was 25 moles per dm cubed. 25 milliliters times the number of moles in the equation, which is 1. And we're going to divide that by the volume of acid used, which was 21.5 moles per dm cubed, times the number of moles of base, which is 1. And we obtain a figure, 0.58 moles per dm cubed for the concentration. Concentration of the acid in moles per dm cubed after you have done a titration. Concentration of the acid, we need to find the average volume of acid. I performed the my nose is itchy. Determine the concentration of the acid used. I already know the concentration of the base, which is 0.5 moles per dm cubed. Now, before I can find the concentration of acid used, we need to find the average volume of acid used during the titration. During the first titer, we used 21.5 milliliters. During the second, we used 21.5 milliliters. So if we add that, we get 43 milliliters. To find the average volume, we say 43 divided by 2, and we get 21.5 milliliters as the volume of acid used. Now, the equation for the reaction. Sodium hydroxide plus hydrochloric acid will give us sodium chloride and water. The mole ratio of sodium hydroxide to hydrochloric acid is 1:1, meaning that the number of moles of acid is 1 and the number of moles of base is 1. Now, for the calculation, the concentration of acid used. We are going to use this formula. To find the concentration of acid used, we're going to say the concentration of base times the volume of base times the number of moles of acid divided by the volume of acid times the number of moles of base. The concentration of the base is 0.5 moles per dm cubed times the volume of the base, which was 25 milliliters, times the number of moles in the reaction, which is 1 mole. I'm going to divide that by the volume of acid used, which is 21.5 milliliters, times the number of moles in the reaction, which is 1 mole. If we put that into the calculator, 0.5 times 25 times 1 divided by 21.5 times 1. We get 0.58 moles per dm cubed as the concentration of acid used. We can round that to 0.6 moles per dm cubed. And that is how you find the concentration of acid used after doing a titration.